Alright, hello guys. My name is Han Wen, and today we would like to introduce you the QuickDraw game, shape detection using AWS DeepLens and Alexa Echo device. So first of all, DeepLens is the world's first deep learning enabled video camera for developers, which is also the main platform we use to develop our own project. And here is some of the hardware specification of the DeepLens. Now, I believe you guys already have an idea about the DeepLens. Then, we would like to talk about our project QuickDraw and the mitigation plan about how we changed from our previous crowd counting project to this one. And next, we will show you how we develop the model, pre-process the data, and integrate deep learning project with Alexa. And finally, we will provide a full demo for our QuickDraw project.
Hi, I'm Aaron. In our project about how the DeepLens do object detection work, we can separate to two parts. And the first part is the cloud to device part, and the second part is the device part. In the cloud to device part, we will deploy our deep learning model to AWS SageMaker and use the Lambda function to connect with our DeepLens. And in the device part, after the DeepLens capture the frame in real world, and we will do some work like the camera calibration and preprocessing our data. And then the Lambda function will be triggered by this input data and send this image to our model. After the model finishes the detection, it will send back the result and trigger another Lambda function to show the output. We will get the output, get two output. One is the device string and the other is the project string. The project string means it will show the detection result with the original image. And let's talk about the QuickDraw game. In the QuickDraw game, we will use the Alexa Echo as an interface to interact with the players. It will tell the players the game rule and lead the players step by step. It will also assign what the object the players should draw, and then the DeepLens will capture what the players draw in the whiteboard. Our model will start the detection work to tell if the player draw the right object or not. The player who draw the object in less time and with more accuracy will win the game. And about our mitigation plan, in the last semester, our model is about the human detection work, but it will include some privacy issue. So in this semester, we change our plan to the QuickDraw game. And in our project, we use the Alexa as an interface to interact with the players and the DeepLens as a camera monitor to get the detection result. So we also need to use the Lambda function to connect the Alexa and DeepLens. In the first stage, we focus on the Alexa part. We design the game procedure and the content and how the Alexa interact with the players. In the second stage, we try to processing the data. We need to let the model to use our data. And in the third stage, we train the model with the QuickDraw game dataset. And in the last stage, we try to put everything together and record the demo of our project and make sure the pipeline can work. And our teammate Saren will introduce the model design.
So I'll take you through the dataset and the model development. So for this project, we got the data from the Google QuickDraw dataset, which is basically a repository where they have images for around 300 daily objects which are drawn by people in the Google QuickDraw game. So the datasets looks like this. We have 28 cross 28 binary images, as you can see here. This is a sparkle, and this is the diagram of an eye. So the interesting thing or the challenging thing about these images is that they have a very small size, 28 cross 28, plus they don't have color information. So if you have two spherical objects, there is a good chance that your algorithm might classify them as the same object. So we randomly picked 36 fairly distant labels which don't look like each other, and for each class label we had around 200k images available, But due to space constraints, we only decided to take 2,000 images, out of which we distributed it into training and test split, which is 1,600 images for train and 400 images for test. And for the model part, we chose ResNet 50, well, practically because it has shown good results to distinguish objects on the basis of contours. We took a pre-trained ResNet on ImageNet dataset, but since they're natural images, uh, it knows how to detect the shapes. So a pre-trained model gave us a good start to train, and the model achieved 95%, 95.4% accuracy on training data and 93.1% accuracy on the test data. And Hanwen can go on to the next slide and talk about pre-processing.
Data preprocessing is one of the most important steps for our project. After DeepLens capture the picture, how should we locate and extract the drawing area that we're interested in? Before preprocessing, we found that DeepLens actually using an ultra-wide angle camera to get as much information as possible in one frame. This also leads to a severe problem that any input frame will be distorted, especially for the paper or whiteboard's rectangular shape. And that is conflict with our preprocessing, which is a computer vision-based mathematical algorithm to detect the lines intersection and the corners. Thus, we need to do a fisheye calibration first to straighten the edges. So to calibrate the lens, since different lenses have different optical designs, thus each type of the camera will have its unique parameters that describe the characteristic of the lens. So we get these parameters first and undistorted the input frame. Then it comes to our actual preprocessing part. Locate the drawing area from the frame and extract the area. So first, we will enhance the initial image and then do the threshold to eliminate the impacts caused by different lighting conditions. Then, we separate several major areas from the frame and found those edges with closed contours. And next, we crop the major closed rectangular contour and then do the perspective transformation so that we could use DeepLens from any inclined angles. And finally, we will enhance the cropped image again, and then we will reverse the color to make it consistent with our model input.
Hi guys, I'm Jack, and I'm going to talk about the integration with Alexa. We developed a AWS Lambda function that triggers Alexa skill and retrieves a data stream from AWS Kinesis to get the outputs from the model. As you can see from the picture on the right here, this is the workflow for the implementation and integration of the AWS DeepLens and AWS Echo. And we have purely allowed our users to initialize and play the game through purely voice commands. We also revamped the interaction flow to suit our QuickDraw game. We designed customized interaction stages for the users to go through and have the commands to be recorded to go on to the next stage. And we have Brian here to further expand more onto the interaction flowchart of the Alexa Echo.
I'm Brian, and I'm going to talk about Alexa interaction for QuickDraw game. So here is the flowchart for this game. Whenever you want to play the game, you can always trigger Alexa Echo device by saying, Alexa, play QuickDraw with DeepLens. And in here, Alexa will give you the rules of the game if you're not familiar with it. Then it's going to ask you the number of players that are playing the game, and it's going to ask you if you're ready to play. And then here, Alexa will give you an object to draw, and you will have 12 seconds to draw that object, and then Alexa will have 8 seconds to guess it. If Alexa can guess what she asked you to draw, then you win 10 points. If she doesn't recognize what that is, you don't get anything. Then after 2 rounds, Alexa will let you know the total score that you have, and if you have the highest score in the game, you are the winner. In doing this game, there's a lot of logics that built in this game. Let's say for this situation right here, if Alexa asks you, "Can I start guessing now?" and then you keep saying no twice, you're not getting any point for that route, even though you do something that's correct. And then during this game, if you want to cancel the game at any point, you can always say, "Alexa, cancel the game," and it's gonna jump into here and it said, "Thank you for playing. Have a nice day." So now I'm gonna show you a demo of the game.
The last stream is from a DeepLens located in front of a whiteboard. Now I'm going to do a demo on Alexa Echo device. Alexa, play QuickDraw with DeepLens.
Welcome to QuickDraw game. If you're not familiar with the game, please say tell me the rules. If you already know the rules, do you want to get started now?
Tell me the rules.
In QuickDraw, you can have up to 4 friends to play. In each game, there are 2 rounds, and in each round, I will ask you to draw an object, and you will have 12 seconds to draw and 8 seconds for me to guess what you're drawing. After that 8 seconds, if what you're drawing matches what I asked, you'll get 10 points. Otherwise, you'll get nothing. Whoever has the highest score after 2 rounds will win the game. If you want me to repeat the rules, say repeat the rules. Otherwise, do you want to get started now?
Yes.
How many players are there playing the game?
2.
I see there are 2 players. Are you all ready to play?
Yes.
This is round 1 and player 1's turn. Your object to draw is I. Start drawing now. Can I start guessing now?
No.
Can I start guessing now?
Yes.
I see a sun. Oopsie. I didn't see what I asked you to draw. Your current score is 0. Player 2. Are you ready for your turn?
Yes.
This is round 1 and player 2's turn. Your object to draw is sun. Start drawing now. Can I start guessing now?
Yes.
I see a sun. Nice job. You won this round. Your current score is 10. Round 1 has finished. Player 1's score is 0. Player 2's score is 10. Are you all ready for the next round?
Yes.
This is round 2 and player 1's turn. Your object to draw is umbrella. Start drawing now. Can I start guessing now?
Yes.
I see umbrella. Nice job. You won this round. Your current score is 10. Player 2. Are you ready for your turn?
Yes.
This is round 2 and player 2's turn. Your object to draw is bow tie. Start drawing now. Can I start guessing now?
Yes.
I see a bow tie. Nice job. You won this round. Your current score is 20. Round 2 has finished, and that's the last round. Player 1's total score is 10. Player 2's total score is 20. So the winner is player 2. Congratulations! You won the game. Thank you for playing QuickDraw. I hope you had an amazing time.
And for the future work of our project, we expect to expand the model to cover a larger variety of objects, ranging from non-essential to essential objects, so that the users can have more options to play around with. We also want to discover a more robust edge detection algorithm for our drawing frame so that our users can be no longer limited to a set amount of backlight or a set tilted degree of the drawing surface. And we want to implement a machine learning method for the drawing detection so that the users can be more flexible on the drawing frame with faster response time. We also want to add more interaction stages to the Alexa flowchart and allow for more options for the users to command so that the game can be more forgiving for the user and also more interaction stages to play around with. Lastly, we want to include more languages so that the users from around the world can also enjoy our product.